Alright, types of numbers. So this should be a review for us. Hopefully these numbers all sound familiar to you. So some key vocabulary. Vocabulary is always going to be in red for us. Examples will always be in purple. So a real number is a positive and negative numbers. Meaning it's the numbers we are used to. So a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fractions, decimals. Basically, almost any number you could think of, it was considered a real number. So those are our real numbers. And opposite that is our imaginary numbers. Imaginary numbers are numbers that include I. And just remember, I is equal to the square root of negative 1, which technically we can't have a negative underneath the square root. That's why we call it imaginary. So examples would be like 3i, negative 5i, just plain old I, 15i, 2/3 I. Anything with an I is considered your imaginary number. But there's also these numbers that are known as complex numbers. These are expressions with a real number and an imaginary number. So for example, 4 plus 2i, 16 minus 15i. See, it's an expression. We got a real number plus or minus an imaginary number, a number with an I. So if it's an expression, it's considered a complex number. Okay. Next we have rational numbers. These are numbers that can be written as a fraction. So, for example, if we look at 5, can 5 be written as a fraction? Yeah, it's 5 over 1, right? Okay, 4.32, can it be written as a fraction? Absolutely. So basically, any decimal that terminates, a terminal decimal that stops and doesn't continue forever, is a rational number. Or if we do have a number that goes on forever, if it is a repeating decimal, it is considered a rational number. So 4.33333, we can turn this into a fraction. Okay, so this is considered a rational number. Obviously, fractions are considered rational numbers because any number that can be written as a fraction. And then we put a negative 17 out there as well because negative 17 obviously can be written as a fraction. Okay, integers. Integers are our counting numbers. So just our regular numbers that we normally count with ever since you were a little kid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's also their negatives. Negative 1, negative 2, negative 3, negative 14, negative 17. So any of our counting numbers. So they don't include decimals. They don't include fractions. It's just our regular counting numbers. Okay? And then we have our whole numbers. Our whole numbers are our positive counting numbers and 0. So, for example, we have 0 and then all of our positive numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All the way up to whatever number you can think of that's positive. Next, we have our natural numbers. Okay, natural numbers are just our positive counting numbers. 1, 2, 3, 4. Does not include 0. 0 is a whole number, but not a natural number. 0 is not natural. I don't know. So, I guess it's not natural to be neutral. You either need to be one or the other. So, just our positives. And then, last but not least, we have our irrational numbers. Okay, these are numbers that cannot be written as a fraction. So, if we look at our examples, grab a pen right here. Okay, pi. Pi is 3.1415 and on and on and on. Pi goes on forever and ever and ever. It never stops. And there is we can't find a pattern to it. There's no rhyme or reason to it. Therefore, we can't write it as a fraction. The square root of 3. This is also a decimal that has no rhyme or reason, meaning there's no pattern, and it goes on forever and ever and ever. And so, on this one, I probably should make it go ... So, basically, if it's a decimal that goes on forever with no pattern whatsoever, it is considered an irrational number. Okay, remember, if it stops, we can write it down, and it could be considered rational. However, if it doesn't stop, it goes on forever, there's no pattern, It's irrational because we can't write it as a fraction. Okay? So your assignment is going to be taking a number and figuring out what type of number it is. And it can be in multiple clubs. It can be in multiple different types of numbers. Here is a diagram that will help you with this assignment. We have real numbers, so basically anything inside the black oval here would be considered a real number. So if you're inside the red circle, if you're a rational number, you're also considered a real number. If you're inside the purple circle, you're considered an integer, but you're also inside the red circle. Does that make sense? And the black oval. So if you're an integer, you'd be all three of these. If you're a whole number, you'd be a whole number, an integer, a rational number, and a real number. And a natural number would be all of these. Now, if you're over here in this irrational circle, are you considered a rational number or an integer? No, because if you're over here, you're not inside any of these circles. You're only inside this yellow circle. You'd be considered a real number, but not any of these. And then we have our complex numbers and imaginary numbers over here, because they are not real numbers either. So let's take a look at -4. Let's look at our diagram to help us out. Okay, is -4 a real number? Yes, it is, because there's no I connected to it. Is it a rational number? Can you write -4 as a fraction? Yes, you can. It's -4/1. Is it an integer? Is it a counting number, either positive or negative? Yes, it is. Is it a whole number? Is it 0 or a positive counting number? It's not. So -4 would get placed right here. And it's inside the purple circle, the red circle, and the black oval. So it is considered an integer, a rational number, and a real number. So on my assignment, I would write irrational, or if you just want to abbreviate, that's fine. Not irrational. Well, I don't know what I'm thinking. Sorry. It's an integer. That's the word I'm looking for. It is an integer. It is rational. And it is real. Okay? Alright, so let's take a look at 2/3. Is 2/3 a real number? Yes, it is. There's no I connected to it. Is it a rational number? Can I write 2/3 as a fraction? Yes, because it is a fraction. Integer. Is it a counting number? No, it's a fraction, so we're going to put it right here in the red circle. And if it's inside the red circle, it's also inside the black oval. So it is a rational number and a real number. So rat and real. Okay, 3 plus 2i. Is 3 plus 2i a real number? No, because there's an I. So come over here. Is it a complex number? Yeah, remember complex number is my expression. 3 plus 2i. Okay, so it's inside this gray oval. Is it inside the tan oval? Nope, just the gray one, so it's just considered a complex number. So we're going to come over here, and we're going to say it is complex. Okay, pi. Kind of talked about pi already. Okay, is pi a real number? Yes, it is, because there is no I connected to it. Is it a rational number? Can I write pi as a fraction? I cannot. So it's going to come over here as an irrational number, because it cannot be written as a fraction. So it's irrational, but it's also considered a real number, because we're inside the black circle, or black oval. So if I come back to my assignment, I'm going to say it is irrational and real. Okay, the square root of -16. Okay, this is also, we can also write this as the square root of -1 times the square root of 16. That's perfectly legal. And I know the square root of 16 is 4. And the square root of -1 is I. So the square root of -16 is really 4i. So if I take a look at 4i, is it imaginary? Or is it real? No, because it has an I. So we're going to come over here, and it is right here in my imaginary numbers, 4i. Now, if you're just a regular imaginary number, it's actually also considered a complex number as well, because technically we could say 0 plus 4i and make it an equation. So 4i, if it's an imaginary number, it's imaginary and complex. Oops, wrong way. So we're going to say imaginary and complex. Alright, well what about 0? Where would the number 0 go? Is 0 a real number? Yep, because there's no I. Is it rational? Can you write it as a fraction? Sure you can. 0 over any number you want. Is it an integer? Is it a counting number? Yes, it is. Is it a whole number? Yes, it is. Is it a natural number? It is not. By definition, it is not a natural number. So if we're looking at 0, 0 would be placed right here as a whole number, an integer, a rational number, and a real number. Alright, let's look at last one I should have had on the other screen. Let's look at the number 17. This is my favorite number, for whatever reason. Is 17 a real number? Yes, it is. No I. Is it rational? I can write it as a fraction. Is it a counting number? Yeah, we learned the number 17 a long time ago. Is it a whole number? Is it a positive counting number, or 0? Sure it is. It's positive. Natural numbers are just positive counting numbers, which 17 is. So 17 would come in here. And if you're in this circle, you're in the green, blue, purple, red, and black. So you would be considered a natural number, a whole number, an integer, a rational number, and a real number. See, so this guy's in a lot of clubs. Okay, so your assignment is just to basically categorize the numbers to figure out which club they belong in or what type of numbers they are. And so go ahead and get on with your assignment. If you have any questions, let me know. And that is the end.